Hi, and welcome to Scientifically Explained. What is machine learning? You use it dozens of times every single day, and yet almost nobody can actually explain what it is. So let's fix that, completely, from scratch. It's already everywhere. When Netflix somehow knows exactly what you want to watch. When your phone unlocks just by looking at your face. When spam never reaches your inbox. When maps predict almost the exact minute you'll arrive. When your bank flags a stolen card in a single second, or your keyboard finishes your sentence for you. All of that is machine learning, quietly working in the background. But what is it, really? To understand it, we first need to look at how computers normally work. Traditionally, we program a computer with rules. A human writes out every instruction by hand. You give the computer the rules and the data, and it gives you answers. Machine learning flips that completely around. You give it the data and the answers, and it figures out the rules all by itself. That one flip changes everything. So let's make it real. Imagine you show a computer an apple, then another one, a green apple, then a small one, then a big red one. Each time, its camera captures the picture, and the data flows in. And every single time you tell it, this is an apple. After enough examples, you switch learning on, and the machine starts noticing what all of these apples have in common. It's finding the pattern. Now for the real test. You show it an apple it has never seen before, and it says apple. It didn't memorize your photos. It learned the idea of an apple. That right there is machine learning. So here is our first definition. Machine learning is software that finds patterns in data, instead of being told every rule. You show it examples, and it learns the rule for itself. And its fuel is data. Data is the textbook. The more good examples you feed in, the smarter the model that comes out. No data, no learning. Every machine learning system has three parts. The data, which is your examples. The model, which is the pattern finder. And training, which is simply practice. Put those three together, and a machine begins to learn. Now look closer at the data. Take our apple again. Its clues, the color, the size, the round shape, the little stem, those are called features. And the answer we actually want, apple, is called the label. Features go in, and the label is what we want to come out. Let's try a classic example. Predicting house prices. Each dot here is a real house. Bigger houses tend to cost more. The model's job is to draw a line through these dots that predicts the price. At first, the line is a poor fit, and those gaps between the line and the real houses, that's the error. Training is just the process of shrinking those gaps. But how does it shrink them? Picture the error as a giant valley. The model starts somewhere up on the slope, and it takes one step downhill, then another, then another. Each step means a little less error until it rolls all the way to the bottom, the best answer it can find. Scientists have a fancy name for this. Gradient descent. The gradient simply points downhill, and descent just means follow it. That is honestly about 90% of how models learn, and we can actually watch it happen. This curve is the error over time. Every full pass through the data, what we call an epoch, the error drops. Down and down and down. That falling curve is the sound of a machine getting smarter. Now, machines don't all learn in the same way. There are three main flavors. The first is supervised learning. This is learning with an answer key. Every example comes labeled. This is a cat. This is a car. It's like studying with flashcards that already have the answers on the back. And it's how most of the AI you use today was trained. The second is unsupervised learning. Here, there are no labels at all. You just hand the machine a big pile of data, and it discovers the hidden groups entirely on its own. This is how systems find different types of customers, or quietly group the songs and products you're most likely to enjoy. The third is reinforcement learning. Think of training a dog. The agent tries an action, the world responds with a reward or a penalty, and over time it learns which choices pay off. This is exactly how AI taught itself to beat the best humans alive at chess and at Go. But for the very hardest problems, like seeing and understanding language, we need something more powerful. So we borrow an idea from the brain. Meet the artificial neuron. It takes in several inputs, and each input is multiplied by a weight, a number that decides how much that input matters. It adds them all up, and if the total is strong enough, the neuron fires, sending its signal onward. One neuron on its own is simple. But that is exactly the point. because when you stack thousands of them into layers, you get a neural network. Information flows in on the left, gets transformed at every single layer, and an answer comes out on the right. Every connection carries its own weight, and learning means tuning millions of those weights at once until the whole network gets the answer right. And here's the beautiful part. The earliest layers learn very simple things, just edges and lines. The next layers combine those into corners and textures, deeper still into eyes and ears and shapes. And by the final layer, the network recognizes the whole cat. Simple parts building all the way up into understanding. So how does it actually learn? The network makes a guess. Then it checks how wrong that guess was. And then it sends that error backward through every layer, gently nudging each weight to do a little better next time. This is called backpropagation. Repeated millions of times, it is how a network learns from its own mistakes. Now, these ideas are actually decades old. So why did AI suddenly explode around 2012? 3 things finally lined up at the same time. An ocean of data from the internet, powerful new chips called GPUs to crunch it, and clever new algorithms. Together, they lit the fuse, and that fuse is still burning today. Every single one of these is machine learning. ChatGPT and large language models, AI image generators, the vision inside self-driving cars, AlphaFold, decoding the shape of proteins, medical diagnosis, cybersecurity, all of it, the very same core idea. The engine behind today's chatbots is called a transformer, and its secret trick is attention. As it reads a sentence, it lets every word decide how much to focus on every other word, all at the same time. That is how it grasps context and meaning. And it's why modern AI can feel so remarkably fluent, and the scale of it is staggering. A single large language model can hold over 175 billion tunable weights, trained on a huge slice of the entire internet. That is a number almost too large to picture, but bigger is not always better. Imagine 2 students. The first one memorizes the practice test, word for word, and then falls apart the moment the real questions change. The second actually learns the underlying concept and can pass almost anything. When a model memorizes instead of truly understanding, we call it overfitting, and it is the #1 trap in all of machine learning. The fix is simple, but clever. We split our data into 3 piles, most of it to train on, some of it to fine-tune with, and one final slice the model never sees until the very end, its real exam. You only ever judge it on data it has never seen before. This leads to a delicate balancing act known as the bias-variance trade-off. Too simple, and the model misses the real pattern. Too complex, and it just memorizes random noise. The magic lives in the sweet spot right between the two. Now, a quick reality check. For all of its power, a machine learning model predicts, but it does not truly understand. It has no common sense. That comes with a serious warning. A model learns from our data, which means it also learns our patterns, including our mistakes and our biases. Feed it a flawed history, and it will repeat that unfairness at massive scale. We used to write out every rule by hand. Now, we simply show machines enough examples, and they write the rules for us. That is a genuinely new way to solve problems. So here it is, from start to finish. Data goes in, a model finds the pattern, training shrinks the error, and out come the predictions. That is machine learning, the entire idea, in a single line. So the next time your phone recognizes your face, or an app finishes your sentence, you'll know exactly what's happening underneath. It learned it from examples, just like you do. If this video finally made things click, go ahead and subscribe. And come back anytime you need it to click again. Stay curious, ask questions. And thanks for watching Scientifically Explained.